What I want to do in about probably sort of 25 minutes or so is talk through the essence of the river environments and their management sort of program at sort of Birmingham. So it's a one-year MSc program. It's possible to do the program sort of part-time over 2 years. At the moment, I sort of co-lead this sort of program with my sort of colleague, sort of Greg Sambrook-Smith. But as we'll see later on, there are a number of other colleagues that are sort of heavily involved in delivering individual modules on this sort of program. In terms of the river environments and the management sort of program, essentially when we're looking at sort of river environments and we step back and we think what we mean both by river and an environments, we need an interdisciplinary sort of perspective to be able to appreciate the interaction between the fundamental sort of sciences, sort of chemistry, biology, and the hydrology and the geomorphology of these sort of systems. But when we look sort of globally, rivers, their catchments, their sort of watersheds, and the ecosystem services that they provide are experiencing significantly increasing sort of pressure, and that's both with respect to our sort of trends in our unsustainable use of water, abstraction of river water and groundwater. The degree to which the rivers are increasingly sort of managed, impounded, or sort of canalized, and impacted also by sort of changes in, well, in some cases, inappropriate sort of treatment of effluent from urban areas and from rural areas. And this is also contributing to increasing sort of degradation of habitats within river catchments. And these impacts are further compounded by the effects of sort of climate change. And that might be changes in sort of precipitation dynamics, it might be sort of changes in sort of temperature. And the management sort of program at sort of Birmingham is to draw together this sort of interdisciplinary sort of background to provide the sort of training that catchment and river managers need if they're to be able to sort of study and manage these environments, mitigate the effects of pressures and improve their sort of status. So the sort of key challenges that we have within river systems and their sort of catchments, they are multifaceted, they're multi-dimensional, and no one sort of individual or no one sort of academic discipline is able to be able to sort of study or sort of quantify or address all of these sort of problems. And so if we look at the key challenges that we see sort of globally, we are living in a time of increased population growth, but also increased per capita water demand. We are seemingly living within a sort of time of increases in the frequency of hydrological extremes. So that's sort of both too little water and sort of too much water. We have water bodies, both sort of surface and subsurface, that are in some cases quite heavily polluted, both by current activities, but also sort of legacy effects. And we have problems with eutrophication, with algal blooms, with invasive species. And at the same time, we have the problems of really how to sustain and protect and perhaps enhance the ecosystem services that we rely on increasingly within sort of catchments. And so if we just sort of scan through these sort of images, we see up at the top just the importance of, say, sort of population. We see, so wastewater treatment works in the middle, problems of agricultural sort of land management. We see invasive sort of species, sort of crayfish on the bottom, problems with hydrological extremes and sort of droughts with that sort of chalk river in the middle. And then the image on the left-hand sort of side is an image that sort of colleagues and I sort of put together so recently, sort of looking at the effects of low flow, but on sort of nutrient sort of fluxes and sort of problems of effluents and flowing to urban rivers. And so it's looking at the effects here of trying to sort of quantify the ways in which water moves through an urban system, and thinking about how dynamic these are and how they change both sort of seasonally and during individual events. So The sort of problems, as I suggested, I mean, they're multifaceted, they're multi-dimensional. They span a variety of sort of different sort of systems, ranging from, say, the River Thames that we see in the top left-hand side, top right-hand side. If we're in an open sort of lecture, I'd ask if you sort of recognise where the lower left image is, but that's the River Elbe in sort of Hamburg that, to many sort of perspectives, has a similar problem to the River the River Thames. And what we see on the lower right sort of image is perhaps arguably also a semi-natural sort of analogue, a natural river system that we can sort of use as perhaps a benchmark of what we might seek to strive if we're looking to consider how sort of rivers and their catchments can be sort of managed in a more sort of integrated way. But so moving from the very sort of heavily anthropogenic and impacted systems of the other images to something that is a little bit more, sort of significantly more sort of natural. So what I'd sort of like to do sort of now is just sort of illustrate some of these sort of wider interdisciplinary problems with respect to some work that I'm sort of doing with sort of colleagues around sort of Europe, sort of looking at the rivers of Danube and the Danube Basin, in the sense that river problems and problems of managing rivers, they are interdisciplinary, they require interdisciplinary understanding. And to a large extent also it requires an appreciation of some of the social and the political sort of problems and the contexts of individual catchments. So the River Danube here that we see sort of flowing from sort of west to east into the Black Sea, it has quite a sort of dramatic sort of topography that we sort of see here, rising in the Alps, crossing the Hungarian plain, flowing through the Carpathian Mountains, before sort of flowing out to the Black Sea and the Danube's delta. It crosses all 10 countries. It has it covers approaching 8% of the European sort of landmass, with a total sort of catchment area of 817,000 square kilometres. But in a system like this, the way in which the river is managed in the headwaters in Austria has significant impacts for water availability or fluvial geomorphology, sort of downstream in sort of Hungary, and sort of further sort of downstream on the Danube in Romania. And the essence of the problems that we sort of see in sort of systems like this are how to reconcile the different management activities within the whole sort of catchment. And historically, with river systems generally, we've lacked the holistic approach that's absolutely essential to look at systems like this. The problems include, say, reconciling hydropower, whether for securing water supply or for hydroelectrics or power generation, how to protect against the flooding, how to ensure sort of navigation throughout the year, how to accommodate sort of changes in land use, changes in agricultural practices that themselves can contribute to point and sort of diffuse pollution. And so the Danube it itself exemplifies many of the problems that we sort of see in sort of catchments, river catchments sort of globally. It's characterized by unique endemic sort of species like the sort of sturgeon that we sort of see here that are sort of critically endangered because of the piecemeal management activities, particularly sort of dam construction that we sort of see in the throughout the whole of the Danube sort of catchment. So if we look at the Danube River, over the last sort of 300 or so years, it's been sort of heavily sort of managed and heavily sort of canalized. This image shows the situation of the Danube River near the city of Vienna, to the lower sort of part of the image. The current sort of situation for the rivers of Danube is a single thread sort of channel, sort of shown in sort of blue. But if we were to go back to the 18th century, we can see that we had a multiple sort of channel sort of system with a river that was slowly migrating across its sort of floodplain with sort of river cutoffs and sort of so on to different points of the visible on this old sort of map. But throughout much of the mid and the lower reaches of the Danube, the river has been canalized. That might have provided some intermediate protection against the flooding. It's certainly facilitated some navigation, but it's increased the rate of conveyance of water. So it's led to compounded problems of floodings or downstream. And it's led to the loss of the disconnection of sort of rivers and their sort of floodplains. And that essentially sort of characterizes the situation with many rivers sort of globally, the degree to which rivers have been sort of managed in isolation from the wider sort of catchment, but where there's been insufficient consideration of some of the wider environmental problems that can sort of contribute to. So to illustrate the scale of the problem, this is an image of showing the distribution of dams in the upper sort of Danube. It's a sort of map that was produced by the ICPDR, the International Commission for the Protection of the Danube River. And it sort of shows that as a result of the drive to develop sustainable energy, there's been the distribution of dams is almost ubiquitous. And so when you travel in Austria, when you travel on the trains, all the energy that's driving Austrian railways comes from their own hydropower plants. But that clearly, that's a drive to develop some hydropower plants has had enormous sort of impacts on the river system, on the headwaters of the Danube. And you appreciate that when you sort of step back and you look at the wider sort of situation across the Danube basin. So we see sort of consequences of management activities to the west of the former Iron sort of Curtain, and we see other sort of tributaries that are regulated to a much lesser extent. But the problem is, given the current sort of situation, should we seek to develop more hydropower plants? Should we try to protect some of the free-flowing reaches of the Danube? And can we reconcile the development of hydropower plants with the impacts on sort of species like the sturgeon and the drive to improve navigation and enhance sort of flood control? So some of these dams are really quite large, and I've just circled the Iron Gates 1 and 2 dam on the Danube, where the Danube flows through the Carpathian Mountains, which is an enormous complex which has led to significant sort of changes in both sort of sediment fluxes, but also in sort of trapping, for example, say microplastics in impounded reaches above that sort of dam. So when we look along the Danube as a whole, its total length is approaching 3,000 square kilometers, but there are 3,000 kilometers, but there are only now five free-flowing sections of the River Danube. Below Iron Gates 1 and 2, immediately above the impounded stretches of Iron Gates 1 and 2, and then sort of three small reaches higher up within the catchment. And so that presents significant problems from almost like a geomorphological perspective, which is challenging catchment managers who are encouraged by the European Union at the moment to open up the Danube as a channel for navigation with connections through to the River Rhine up to the north. So how do we reconcile this? We have some problems with river regulation. We have problems with changes in the geomorphology of the system, changes in shear stress. We have areas immediately downstream of dams where, because the river is starved of sediment, we see riverbed erosion. But conversely, we see areas during low water where navigation is no longer feasible without quite extensive dredging. And so problems like this, actually, to my mind, they emphasise the need to perhaps think in a more integrated way about how we can reconcile conflicting stakeholder needs. They also rely upon a more holistic perspective of the way in which the river basins should be managed, thinking about how processes may differ in the headwaters, how we might have reaches downstream where both the water and sediment would naturally be transported efficiently, but which in many catchments has been quite heavily regulated. And then we have questions sort of further sort of downstream in the so-called sort of depositional zone, which would relate or for many catchments to parts of the basin which is quite heavily sort of populated, but which is vulnerable to coastal flooding. And so from an interdisciplinary sort of perspective, we have enormous sort of opportunities to bring together sort of new advances in terms of satellite remote sensing, in terms of broad-scale environmental modelling, to look to see how we can develop some different scenarios of how sort of river catchments may sort of change into the future. And that's, in a nutshell, really sort of presents the motivation for the river environments and their sort of management sort of program. It's the desire to provide you with sort of key sort of core sort of competencies to appreciate the interdisciplinary sort of background to river basin sort of management, to think about how it might be so possible to sort of draw on some new techniques to identify sort of ways of characterizing the current sort of state of sort of rivers, to think about how we can better identify sort of cause and effect, to track pollution, for example, say microplastics through sort of river basins, to identify ways in which it might be possible to restore individual sort of rivers and river reaches to enhance the ecosystem services that these rivers provide. I think this sort of emphasis on things like sort of restoration is really sort of quite an important sort of new and sort of developing sort of opportunity. The degree to which we can take, in some cases, quite significantly sort of degraded reaches, to consider perhaps the geomorphological sort of dynamics that these catchments would sort of naturally experience, and consider how we can also renaturalize and restore these sort of reaches to improve their sort of diversity and the river functioning associated with those systems. So, in terms of the master's sort of program, it's if you were studying the MSc, you would take 180 sort of credits. 120 credits of those of which are within sort of taught modules, and there's a 60 credits of dissertation. What we would assume is that for a full-time sort of person studying on the program, it will be the equivalent of about sort of 4 days a week, but sort of part-time, sort of 2 days a week. Total contact hours in excess of sort of 200 hours, and the teaching methods are sort of diverse. Clearly, at the moment, the program is largely been it's been delivered in a blended fashion with recorded lectures, synchronous online sort of lectures, and face-to-face of teaching in some sort of cases, but with some tutorials added. And what we'd anticipate of next year is that we would we still have the resource of the recorded lectures that you'll be able to sort of use, but as the wider situation improves, there should be sort of we should be reverting to more sort of face-to-face sort of teaching, as we have done in sort of previous years. The modules that you also take are designed to move you quickly, almost from first principles up to relatively advanced sort of applied sort of knowledge and applied sort of science. So the modules that you were to take, they're all compulsory. But we'd appreciate that some of you would have perhaps a reasonable background in some of these areas. The modules include hydrogeomorphology and catchment management, which I teach with Greg Sambrook-Smith, river ecology theory and practice, that's taught by Mark Ledger, quantitative analysis of hydrological processes, that's taught by sort of Stefan Kraus and Josh Larson. And then we have advances in water science and river management that's taught at the moment by Mel Bickerton and a number of others, teaching sort of seminars on that sort of module. Environmental analysis and modelling, so taught by sort of John Sadler and sort of Nick Kettridge, and river habitats and biogeochemistry, so taught by Rebecca Bartlett and Mel Bickerton. And on top of those sort of taught modules, there's the dissertation that will be sort of completed over the summer. And in total, that adds to 180 sort of credits. So the what we sort of encourage is opportunities for sort of field work. While this has been sort of difficult to do this this year, we're hoping to be able to reintroduce some sort of field work sort of next term. So we'd hope in the next academic year that sort of field work should almost be able to progress as normal. The sort of fieldwork opportunities that you can hopefully see on this screen include the visits to BIFOR, to the Birmingham Forestry Institute in North Shropshire. Include sort of visiting the Centre for Ecology and Hydrology, where we're actually sort of talked here by a former sort of REM student who's now working at the Centre for Ecology and Hydrology. On that sort of same visit, we look at some sort of new ways of quantifying river flow on the River Thames. This is sort of field work on, I think it's sort of on the Birmingham sort of Forestry sort of Institute, and we see sort of other sort of instrumented sites here, sort of relatively sort of close to Birmingham, where we've been sort of looking to see sort of how we can instrument and sort of use new research techniques to quantify the sort of processes within individual river systems. So the program itself, we are sort of closely linked with the physical geography sort of research group at sort of Birmingham, but we're within the College of Life and Environmental Sciences within the School of sort of Geography, and we're able to draw on the range of sort of facilities that are available. Specifically including the Ecolabs facility that some of you may be familiar with, but also sort of drawing on opportunities at sort of BIFOR and opportunities to use some of our sort of lab facilities within the Birmingham sort of campus. What we also sort of encourage is opportunities to do sort of project work that's build upon opportunities for sort of research that the colleagues on the program are sort of doing, including in sort of alpine environments. So this, I think, is actually an image from the, I think, from the Pyrenees, or sort of looking at sort of karst systems that we see sort of down here. In some cases, some of the project work that people do is much more sort of focused on the lab, or also sort of looking at other sort of river reaches where they essentially using the the natural laboratory to look and to understand and say quantify hydro by geochemical processes in sort of real world environments. So the key points to emphasize really within the river environments and the management sort of program is that it is sort of driven by some research that a number of us, in fact, all of the people on the team are sort of doing. It is strongly applied, and so there'll be sort of elements that are sort of practically sort of relevant, which you'll be able to take forward if you wish to work in the arena of say river management in a future sort of working career. And then we do have the individual modules that are delivered in a variety of ways, as I suggested at the moment, using a blended sort of package of delivery, but with increasingly sort of focused on face-to-face delivery, hopefully so next year. You do produce the sort of research-based sort of thesis as was like the culmination of your sort of year of sort of full-time sort of study. But that's closely supervised by a member of sort of academic sort of staff, and so what we'd seek to do there is to work around your own sort of interests around sort of river environments and find a way to accommodate that and allocate a supervisor appropriately. So I think the points to further emphasize is that this is a rapidly expanding sort of field, and I think the nature of sort of river environments, given the interdisciplinary sort of context, means that many of us sort of teaching on the program have different but also sort of complementary sort of skills to bring sort of to it. So my interests are sort of very much as an environmental hydrologist, and I sort of bring on to relate some of my sort of recent sort of work. So, for example, like the Danube, the teaching that I do, but others are sort of much more sort of strongly sort of focused on freshwater ecology and sort of biogeochemistry, sort of fluid sort of geomorphology and so on. And I think the final point to emphasise here is really that there is very high, very good employability sort of figures. Our sort of graduates have gone into jobs in sort of government agencies, research institutes like the Centre for Ecology and Hydrology, local engineering firms, environmental consultancy, and several have also sort of gone on to academia. So two colleagues in the school completed the River Environments and their Management program a few years ago, and we have also sort of current sort of PhD students that sort of completed the program recently. So the core sort of team that we sort of see down here, Rebecca Bartlett teach on the biogeochemistry. I sort of teach from the hydrological sort of perspective. Simon Dixon, who studied the River Environments program a few years ago himself, is more interests that span sort of water quality to natural flood management. Stefan Kraus, sort of biogeochemistry and sort of hydrology. Joss Larson with sort of similar sort of interest. Mark Ledger, freshwater ecology. Sandy Milner needs no introduction. I think he's on the call sort of now. And Greg Sandbrook-Smith. And unfortunately, I missed sort of John Sadler from this sort of list, and Nick Kettridge, who also sort of teach on the environmental analysis and modelling sort of module. So in terms of the program, then I've gone through this sort of fairly quickly, and I was sort of trying to work just to sort of half an hour. I mean, we clearly have some time for questions, as Vanessa said at the start. I've not talked through about the what we're looking for in terms of, say, sort of backgrounds, but academically we are looking for the equivalent of a 2-1 degree, and we would hope that you would have some sort of science sort of background, but the individual modules assume sort of no sort of prior knowledge of that sort of particular sort of subject. And so the nature of sort of master's courses is that it can move sort of fairly quickly, and there might be elements of the program that you've done already, perhaps the introductory part of a module. But what we would hope is that in developing your interdisciplinary sort of competencies, there'll be other parts of the program that you would need to, say, prioritise at certain times of the academic year.